Bismillahirrahmanirrahim. Today what we are going to discuss is basically the shearing force and bending moment diagram, right? The two main concepts will be discussed in this chapter. One is shearing force, that is generally denoted by the V, and the moment that is generally denoted by the M. So we have not yet discussed about the V. That is the transverse shearing force that will be primarily discussed in chapter 6, but here we will be using that concept of that shearing force. And bending moment we have already studied in chapter 4, where we have a moment that causes the bending, and resultingly you calculate the normal stresses because of the bending and normal strains because of the bending. So primarily we will be discussing these two concepts in today's lectures. So let's start with the one note. So I'll stop the video so that the size remains smaller. Right. So what we have, what we are going to discuss is that this is basically the shearing force, and this is basically the bending moment, right? This is the bending moment. Shearing force is generally represented by V, and bending moment is generally represented by M, right? So what we have discussed now, this is basically a beam, and P is a force applied at it, right? And this is the fixed part of that beam, and P may be around 100 pound, right? So if I take a cross section over here, so what will be there? This will be the P force, and this is the action, right? So in action there should be a reaction, and this reaction should be equal and opposite to this one, right? So this will be the force V. This is the shearing force, right? We will discuss in detail this V in chapter 6, but here we are just using the concept of V, right? So now what is happening over here? Now, supposedly this sectional area is A, right? So this is called transverse loading, right? What is the transverse loading? We have discussed in chapter 4 as well. The transverse loading is the loading that is applied perpendicular to the longitudinal axis, right? So this is the transverse force. Whenever you have transverse loading, there is always a equal and opposite force that is called the shear force, right? Now this is the shear force, right? Now this is the A. A is the distance from which I take the section. So now we have dealing with the V, and we are dealing with the M. What will happen to V? My question is, what will happen to V when A will be changed? Any change will be there? No, there will be no change. If I take the section over here, I take the section over here, no matter I take the section over here, V will always be constant. So it will be always constant. It is independent from the A. It is independent from the section I am taking from this particular point from where I am taking. So it will always remain same. Obviously, it may change if I change the loading condition. This is the simplest load, so it will not change. It will always be equal to V if I take a section at any. But what about the M? M we know is a product of load into the length, right? That is A. So when I'll apply the A at this section, it will be different, and at this section it will be different. At this section it will be different because A will be changing, right? And if this whole distance is say 6 feet, so at this particular point, it will be 600 feet, pound feet, right? So in this particular case, if I take the section over here, so V will be 100 pounds, whereas M will be 100 times of a pound fit, right? So it will be, the moment will be keep on changing as I keep on the changing A. But in this particular case, I'm talking about in this particular case, V will be constant. Obviously, if I take any section like this one and I applied over different loads over here, another type of load over here, so P1, P2, and then you have different type of the loading, then definitely V will be changed when I'll change the cross section. But in this particular case, in this particular change, it will be constant across the length, but M obviously will be changing. So M will be changing, right? Now how it will bend? How it will bend? Now this is the basically the beam. Okay, it is fixed from this end, and I am applying the load at this. It will go down in this particular shape, right? So this beam, this particular beam, which was initially in this shape, will go down in this way.